Hello everyone. In this tutorial, I'm going to discuss about Apache Spark. We're going to discuss history of Spark, what is Spark, Hadoop versus Spark, then some component of Apache Spark like Spark Core, SQL, streaming, mlib and graphics. At the same time, we're also going to discuss about Spark architecture, some applications of Spark and Spark use cases. The very first thing we should understand about Apache Spark is one of the big data tools, that is the continuation of one distributed architecture. After Hadoop, when the amount of data is increasing rapidly, MapReduce is not giving the best results that we are looking for, and that is how the Apache Spark availability started in the industry. So somewhere in 2009, started as a project in UC Berkeley in AMP lab. In 2010, Apache Spark has been licensed under BSD license. 2013, Apache Spark became one of the top level project of Apache, and 2014, Databricks has assimilated the feature of Apache Spark and made a world record for the highest amount of large-scale datasets to be processed on their platform. The very first question is, what is Apache Spark? Apache Spark is also one of the big data engine. It's an open source data processing engine to store and process data in real time across various clusters of computer using simple programming constructs. Apache Spark supports various programming languages like R, Python, Java, Scala. And a developer can do query analysis, analyze the data and transform the data on a very high scale. Since we know that Spark is one of the big data engine, Spark is actually doing distributed parallel processing computing with their engine. Now let's have a bit comparison between Hadoop versus Spark. Hadoop was slow because of their MapReduce, and MapReduce is one of the integrated process in Hadoop and also associated with their Hadoop distributed file system and making a cluster manager using Yarn. MapReduce is little slow because it is iterative in process, going every single nodes for breaking down, mapping and reducing and then processing it. Where Spark is 100 times faster than MapReduce as it done in memory processing. Hadoop only perform on batch data. It's only having batch processing, and for real-time analysis, Hadoop has to use additional integrated APIs like Kinesis and other tools, where Apache Spark have their own real-time processing API called Spark Streaming. So Apache Spark process both batch and real-time data. Hadoop has more lines of code since it's written in Java, where Spark has fewer lines of code since it's implemented in Scala. Hadoop supports Kerberos authentication, and Apache Spark can leverage the key management or via shared secret key and use Yarn leveraging capabilities of Kerberos as well as for authentication. Let's talk more features of Spark, that is RDD for fast processing. Apache Spark have resilient distributed data which saves times taken reading and writing, and it runs almost 10 to 100 times faster than Hadoop. As I said, it's in memory processing, flexible, fault tolerant because of resilient distributed data, and resilient is lineage in nature. Also, resilient RDD ensure the data is actually storing and some information, and since because of their lazy evaluation process, it is more fault tolerant. Better analytics can be done because it's have a feature of Spark SQL as well as machine learning, and complex analytics can be done. Some component of Spark, let's have a look. Apache Spark have all the 5 components like Spark Core, that is the base engine, Spark SQL, Spark Streaming for real-time processing, Spark Machine Learning for machine learning integration, Graphics for advanced analytics in graphical form. Spark Core is the base engine, as I said that it is responsible for memory management, fault recovery, scheduling, distributing and monitoring jobs over a cluster, interacting with storage systems, and so on. Since it's used RDD, and RDDs are one of the immutable type of data sets, and that's do transformations and actions. Spark have also Spark SQL, Spark Streaming, Spark Emblem, and Graphics. Since we are not getting more overview right now on these topics, we are moving towards the architecture of SparkX. So if I talk about the architecture of SparkX, Spark architecture, if I talk about, Spark is one of the master and slave architecture, and since it's having a master and slave architecture, it's have a master node, a driver program that's drive the process, and there is a Spark context. Spark context is nothing but it's a gateway for all the Spark functionalities. Like if I wanted to tweak any broadcasting, or if I wanted to tweak any parallelization, if I wanted to do bucketing or anything, Spark, whatever the features of Spark is there, can be utilized using Spark context. So Spark context is nothing but it's a gateway for all the Spark functionalities. Whenever a user write and program to do any manipulation, what will happen in a Spark context? First, it will create an RDD. After creating an RDD, there is one DAG scheduler. DAG stands for Direct Acyclic Graph. This direct acyclic graph is nothing but help us to determine RDD in how many stages, okay, in how many stages that program need to be initiated on multiple cluster. So it's create stages, and every stages have some task defined. Okay. Then there is a scheduler or task scheduler that actually schedule the task to the cluster manager, further cluster manager. So there is a cluster manager. This cluster manager actually let the task to be completed, and and it's run the Spark application in independent set of process on a cluster, and then the driver program in Spark context take care of job execution within the cluster. So this cluster manager could be anything. There are multiple cluster managers. It could be a Spark core, Spark standalone cluster manager. It could be a yarn. It could be a Mesos. It could be a we have multiple other cluster managers also, that is possible. So cluster manager then further send the task to the worker nodes. Then this worker nodes actually let the task to be completed by their executors. So there is executors like this. So there is executors, and then some tasks and some caches are being processed for them. So the job further splitted into multiple worker nodes and let the task to be completed. This is the basic architecture of an Spark. Now, as I said that there are multiple worker nodes, there are multiple cluster managers like standalone, Mesos, Hadoop, Yarn, Kubernetes, and there are multiple applications of Spark also to multiple organizations like JP Morgan used to detect fraudulent transactions, Alibaba used for analyze the large amount of data set for transaction details. IQVIA is one of the leading healthcare company use analyze patient data to detect the health issues, and Netflix for recommendation system and so on. So I will be telling you that Spark can be used by their on different platforms on virtual machines, and there is one Databricks community cloud which can help us to also run the Spark features. So I'm just showing you right now how we can actually use the Spark